So at this point, I'm going to center center drill the end of the part, which will be the bottom, just to hold the live center. That should be good. So this first pass is going to be a really light pass, and it's just to make it round essentially, because what I'm interested in is having a round surface to clamp onto with the chuck so that I can then check for taper, because I don't want there to be any taper, because taper would imply that it's at an angle and not square with the base. So this first cut, I'm just taking off 5/1000ths. In contrast to the 4140 chromoly, this stuff cuts just beautifully, especially with this positive rake insert. It's a mirror finish. Alright, so I just wanted to make sure that my part was not only round, but that there wasn't taper in the shaft. I did notice something on this with this 1-inch indicator that being stuck out like this, that as I move, it'll look like it's going to be off a thousandth, but it's actually not. And that's me if I'm pulling back on the cross slide as I move it, because you can see here just loading and unloading is causing a little flexion in it. But in any case, there's not any really discernible taper, so that's good. So we can move on to facing it and drilling for a magnet I want to put in the bottom to hold it more steady while I'm doing the measurement. So we're going to drill for 15-30 seconds. So next I need to bore this out to 0.499. So ordinarily, this would be a terrible idea with so much stick out, but it's very thick, large diameter, and I'm taking off very small cut and very soft material. Okay, so that last pass got it into 0.499, and I'm just going to deburr it a bit. And then I'm going to test fit the magnet. So this feels like it's going to be a perfect press fit. That's really tight. Just starts. Okay. Alright, so it's parting time. And I won't need to stop and chamfer this because it needs to mate up flush. So we're just going to part away. As I get closer to the middle, the linear velocity actually decreases and the surface feet per minute decrease. So I'm actually going to speed it up, try and keep my cutting speed similar. Gotta make sure to stop periodically and break the chip really close. There we are. I also left this side about 1/10 large on purpose. So in case you were wondering why I left the overall length 1/10 of an inch larger, it's because 4 Thumb McGrew, as he's walking over to put this in here, drops on the ground and dinks the bottom, which is one of the reasons why I was a little hesitant to use aluminum to begin with, because it's so delicate. However, the ways themselves, I didn't want to risk a harder material that would scratch the ways, because if anything gets damaged, I can always make another one of these, and having the ways redone, well, that'd be expensive. So I'm going to face this side again that I bored the 1/2 inch hole, then we're going to turn it over and cut it to length, bore the 1/2 inch hole on this side that will hold the stainless steel portion of this tool. So this next step is really straightforward, but I just wanted to mention it because I'm going to follow the recommendations of a machining book I was reading from the 1940s, and it said if you want the best hole possible, you spot drill, followed by drilling, followed by boring, because the drill roughs out the material, the boring makes it parallel to your axis of your lathe, and finally ream it to size. So I'm going to give that a shot, see how it works, and see if it does a good job. I'd like a really tight fit. Good sign, doesn't sound like it's an interrupted cut, so it sounds like we're pretty much on axis. Alright. I'd have wanted to go a little slower, hindsight. So a little bit of deburr. And just for the hell of it, I'm going to take a measurement, see how close we are. Should be right on. I measured the reamer ahead of time, but almost 1.5 thousandths over. So we'll need to take that into account when we're doing the stainless steel next. So next, I need to turn down this, about 3/4 of an inch of this. This is stainless steel 303. I need to turn down about 3/4 of an inch of this down to 1/2 an inch so that it will be a press fit into the aluminum part. So let's rough some out of here. This is 1 1/4 stock. We're going to try some 100 thousandths passes. Still silver, not blue. So we're definitely not pushing as much as we could. So, let's see, that's on incremental. So we're at about 0.5136. So I need to take one more pass at least, but it's kind of warm, so we're going to let it cool off before we do that. Plus, I think I'm also going to chamfer the end to make it feed into the other part more smoothly. really tight. Won't go on, which is good. Currently 680 RPM, 2,000 per revolution feed rate. Oh, that just starts. Yeah, it just starts. We're really close. I think I could probably fit that on, press fit that on right now. Yeah. Maybe I'll take it down just a tiny amount with sanding. Press fit together really nicely. And now I am going to pin it. So I'm going to spot drill and then ream for 1/8 inch pin. Okay, so we're going to go 3/8 down from the top. This total length of the aluminum part here is 4 inches.